Hi everyone, it's Mrs. Griffin with the Unit 8 Lesson 3 video about angles that are formed by secants and tangents. Please pause the video, take a second to do this opening exercise. And here are your answers to check. On to the notes. Okay, so for starters, we have discussed a tangent already. It's a line that crosses a circle once. A secant is a line that intersects a circle at 2 points. And we've talked about how something that has 2 points in common with a circle is a chord. The chord is this portion of the secant. So the chord is the segment inside the circle from the secant, and the secant's the line. Okay, so the secant's the line, the segment's the chord. Now, when two chords intersect one another, they often form an angle, and notice that angle has a vertex that's not central and it's not inscribed. The vertex is just hanging out in the middle of the circle. That angle, whether it be this or this, because both of those are the vertical angles, they're the same, that would be equal to the average of the arcs. Okay, so you would average your arcs that are intercepted by the two vertical angles, and that would tell you what each one equals. Okay. Now, when two secants meet, we're talking about having them meet on the exterior of the circle. So our point of intersection is now on the outside of the circle. And so this is the angle that we're trying to find. And that angle is intercepting two different arcs. One that's closer to it, it's always the smaller, and one that's further away from it, which is always larger. And when we are figuring out what the angle equals, we're going to take that far arc, subtract the near arc, and then divide by 2. Okay, so I wrote A minus B, but a lot of people remember it as the far minus the near, or the big minus the small, over 2. So 2 ways to write that formula. Now that formula applies whether we're talking about two secants, a tangent and a secant, or two tangents. Okay, so whether we're doing the angle formed out here, we're still getting two arcs, farther and nearer, farther and nearer. We're still going to do that same formula. Remember for the two tangents that those two arcs, because we're talking about tangents that only touch a circle in one spot, will always add up to 360. So often we would only have one of them, and we'd have to subtract to find the other. Or if one of the variables is on those arcs, then you can use 360 minus B to represent A, or you can use 360 minus A to represent B. So one of those could be helpful in a particular equation. All right, so on to some examples. So inside intersection, that's two chords. That is where we're going to do the average of the arcs. So the angle is going to be equal to taking the two arcs, adding them together, and dividing it by 2. So in this particular case, we're looking for angle 1, which is intercepting the 92 degrees, and then look at its vertical angle, which is intercepting the 95. We're going to average those two together. So angle 1 is going to equal 92 plus 95, and then divide it by 2. And that would be 93.5. Okay, same thing here. Angle 1 is what we're looking for. That's intercepting the 38. Its vertical angle is intercepting the 104. So to find angle 1, we're going to average the 38 and the 104 by adding them and dividing by 2. And then what you will get is 71 degrees. Okay, now if we look at this one, angle 1, what we're looking for, would intercept this arc, which we currently don't know. So we're not actually going to be able to find that one first. Instead, let's find its supplement, because its supplement, this x here, is intercepting the 132, and then the vertical angle to it is intercepting the 53. Anytime you do these, it should look like you're dealing with a bow tie. Okay, just like our vertical angles. Maybe a little lopsided, but it's still the bow tie. So if we're going to look for x, we're going to average the 132 and the 53, add those up and divide by 2, and when you do that, you'll get 83.5. Now to find angle 1, these are supplements. So you're going to take that 83.5 and subtract it from 180. And when you do that, you'll get 96.5. All right, now for number 4, you can see now we're dealing with binomials. We're going to have to create an equation. So we have our 132, that is our angle. That is intercepting this 9x minus 10 arc. The vertical angle to it is intercepting the 5x plus 8. So if we follow the formula that the angle is equal to adding the 2 arcs and then dividing by 2, we're going to plug in everything we know. So we know the angle, it's 132. One of the arcs is 9x minus 10. The other arc is 5x plus 8, and then divide by 2. We can cross multiply or multiply by 2 on both sides, however you see it. And you're going to get 132 times 2, which is 264. And then 1 times all of this, because these are being added, really we just have to combine like terms. So 9x and 5x is 14x, negative 10 and 8 is negative 2, and then we can solve. So we're going to add the 2 to both sides, and then we will divide by 14, and we will get that x is 19 degrees. Okay. All right, for number 5, we're looking for angle 1. So we have 2 options here. We can use the supplement and do what we already talked about back when we did number 3. Or, since we have all the arcs except the 1, we can find the missing arc over here first and then just do our regular formula. So either way, if I find the missing arc first, I would add them all up and subtract them from 360, or subtract each one from 360 individually, and I'll get 73. So that arc is 73. So now to find the angle 1, I can just average the 73 and the 37. And that would be 55 degrees. Okay. All right, so for number 6, we have the angle here. It's intercepting the 128, and its vertical angle is intercepting angle 1. I'm going to put an x there, because now since we're looking for an arc, this is going to have to be an equation, because when you fill in that formula, you're going to have your x in the fraction, because we know the angle is 116. X is one of the arcs, and 128 is the other one. So now we're going to have to cross multiply or multiply by 2 on both sides. So 1 times x plus 28, 128 is 1x plus 128. And 2 times 116 is 232. And then when you subtract the 128 from both sides, you're going to get 104. And so the measure of arc 1 is 104 degrees. All right, now, on the back, what we're dealing with is angles where they're formed by intersections that are on the exterior of the circle. So an outside intersection, you're taking the further away arc and subtracting the closer arc, and then dividing by 2. So outside is subtraction. All right, so when we look at angle 1 that we're looking for, it intercepts 2 arcs. This one is closer and this one is further away from the angle. And so we're plugging in. So the measure of angle 1 will equal the further away arc minus the closer arc divided by 2. So 132 minus 48, hit enter before you divide by 2. You're going to get 42 degrees. Okay, on this next one, we have the angle, so we're filling that in for the angle portion on the left. The 2 arcs are intercepted here and here. I'm going to put x here again because if I'm filling in one of the arcs, I'm going to end up with an equation to solve. So my angle is on the left, that's 39 degrees. The further away arc is 134, minus the closer arc, which is my x, over 2. So I'm going to cross multiply. 134 minus x is still 134 minus x when you multiply it by 1. And 39 times 2 is 78. And then 78 minus 134 is negative 56. So when I divide by the negative 1 on both sides, I will get that x is positive 56, and so the measure of angle 1 is, or arc 1 rather, is 56 degrees. Okay, number 9, very similar. We have the arc that we're looking for, so I'll call it x. The angle 28 would be equal to the further arc minus the near arc over 2. Cross multiply. We're going to get x minus 39 equals 56, and then 56 plus 39 would be equal to 95. And so the measure of arc 1 is 95 degrees. All right. Same concept on 10, except when we look at where angle 1 is that we're looking for, it intercepts two arcs, which are here and here. We have the further arc is 160, but we don't have the closer arc. Now keep in mind, the arcs all add up to 360. I have two of them, so if I subtract those from 360, I'll get the third one. So 360 minus 160 minus 128 is 72. Now I can set it up. The angle that I'm looking for, angle 1, will be equal to the further arc minus the closer arc divided by 2. So 160 minus 72, please make sure you hit enter before you divide by 2, and that will get you 44 degrees. Okay, for number 11, we're looking for the arc again, so I'm going to make that one x. The angle is equal to the further arc minus the closer arc divided by 2. Cross multiply. We're going to subtract 149 from both sides, so 86 minus 149 is negative 63. And when you divide by negative 1 on both sides, you'll get 63. So the measure of arc 1 is 63 degrees. All right, number 2. Now number 2, we're looking for both arc 1 and angle 2. The trick here is to realize that if D is the center of the circle, that this is a diameter, and therefore this is a semicircle, so they add up to 180. So to find arc 1, you just have to subtract the 58 from 180, and 180 minus 58 is 122. So arc 1 is equal to 122. And then we can find angle 2 by doing the far arc, 122, minus the closer arc, 58, divided by 2. And that would equal 32. Right, number 13. Number 13, we have two tangents. We still have an exterior angle that we're looking for, so we're still going to do far arc minus near arc, but we don't have the near arc. Remember that the circle adds up to 360 though, so if we do 360 minus 232, you will get 128 degrees, and then you can find angle 2. So the farther arc minus the closer arc divided by 2. So 232 minus 128, hit enter before dividing by 2, and you will get 52 degrees. All right, number 14. Similarly, we don't have all of what we need, but we do see these congruency marks. That means that these two arcs are congruent. They're the same. That one would be 78 as well. And the whole circle would be 360. So if you subtract the two 78s from 360, you will get 204. And that will be this missing arc. And now to find angle 1, we're going to use the far arc over here, the 204, minus the near arc. So angle 1 would equal 204 minus 78, and then divided by 2. That should be 63 degrees. All right, number 15. Similarly, we only have one of the two arcs, so we're going to subtract from 360 to get the other one, and it would be 100. And then the angle is equal to the far arc minus the near arc over 2, so we need to substitute in everything we know. The angle is 8x, the far arc is 260, the near arc is 100, and then divide by 2. So I'm going to do this whole calculation out. 260 minus 100 is 160, divided by 2 is 80. And then I can just divide by 8 and get that x is 10. All right, for number 16, we're back at interior intersection, so we're back to averaging. So the 73 intercepts the 4x plus 6, and the vertical angle intercepts the 56. So the angle is equal to averaging the arcs, because we are crossing on the inside two chords. 4x plus 6 plus 56 is 4x plus 62, equals 146. We need to multiply, subtract 62 on both sides, and divide by 4. For number 17, we're going to do far minus near. The angle is 32. The far arc is 5x plus 24 minus 3x over 2. When you cross multiply, you're going to get 2x plus 24 equals 64, which is 2x equals 40, which means x equals 20. Then finding FE, we're going to substitute back in to get 124 degrees. All right, I will see you in class.